Right now, Earth is the only place we know life exists. We have checked Mars, Venus, the ocean worlds of Europa and Titan, and we still have not found life. But the galaxy is packed with stars, and most of them have planets. So what are the best worlds out there? Tonight, let's visit the most exciting exoplanets and ask a bold question. Could some be better for life than Earth? Super-habitable does not mean Earth clone. It means conditions that could be even friendlier for life. Think long-lived orange dwarf stars that shine steadily for tens of billions of years, planets a bit larger than Earth for more shallow seas and big continents, and climates that change slowly, so life has time to adapt. That is the idea behind the super-habitable shortlist scientists proposed in recent years. First up is KOI 5715.01. The name is not catchy, but the setup is. It orbits an orange K-dwarf about 3,000 light-years away in Cygnus. The planet is still a candidate, not confirmed, but it checked so many boxes in one survey that the authors flagged it as the top super-habitable pick. Bigger than Earth, likely in the star's temperate zone, and bathed in steady light from a star that can live far longer than the Sun. If life got started there, it could have much more time to diversify. Reality check. We do not yet know the atmosphere or exact mass. Super-habitable is a hypothesis to test, not proof, but it shows what to look for. Next is the famous TRAPPIST-1 system, just 39 to 40 light-years away. 7 Earth-sized worlds huddle close to a star about the size of Jupiter and much cooler than the Sun. The whole system would fit well inside Mercury's orbit. That makes for wild skies. From one planet, you would see the others as disks, not points. These planets are older than Earth, which gives evolution time. But there are trade-offs. The star is active, and the worlds are likely tidally locked with a scorching day side and a frigid night side. The best case is a twilight ring with mild conditions and flowing water. What about the air? Big question. Recent analyses with JWST suggest some TRAPPIST worlds could retain atmospheres, but results are mixed and still debated. You will see headlines claim everything from no air to nitrogen-rich. The honest status is inconclusive. We are still collecting spectra and learning to subtract the star's magnetic noise. Kepler 452b is an Earth-sized world on an Earth-like year of about 385 days around a Sun-like star. It is larger than Earth by about 60% in radius. Early modeling suggested a few to several Earth masses, which could mean stronger surface gravity. Exact mass and makeup are still uncertain. If it is rocky, bigger size can mean more tectonic activity and a stronger magnetic field. Both good for life, but its star is a little older and brighter, which might push the planet toward a slow greenhouse over time. People often say, Jupiter protects Earth from asteroids. The story is complicated. Simulations show that removing a giant like Jupiter can actually reduce certain impact rates by cutting down on gravity-driven nudges that send rocks our way. So a system without a big Jupiter does not automatically mean doom from asteroids. Finally, Kepler 22b. It sits in the temperate zone and is about 2.1 to 2.4 Earth radii. That size is right in the fuzzy zone between a big rocky planet and a mini-Neptune with a puffy envelope. It could be an ocean world with deep global seas, or it could have a thick hydrogen atmosphere that is not friendly to life as we know it. We do not know yet. What we can say is that it is one of the first worlds we found in the habitable zone, and it opened the door to this entire search. Here's the real value. These targets teach us how to search. Go after long-lived stars. Hunt for planets a little larger than Earth that keep heat and water well. Watch for atmospheres we can actually measure with spectra. And build the telescopes that can tease out methane, carbon dioxide, and eventually oxygen with confidence. Most of these worlds are far. KOI 5715.01 is almost 3,000 light-years away. TRAPPIST-1 is close by comparison, but still 40 light-years. Even with breakthrough propulsion, these are multi-generation missions. So for now, our best path is light. We read the chemistry in those thin bands when a planet passes in front of its star. That is how we will find the first real signs of life.